Let's look at our first topic in this lesson, topic A, support vector machines. When dealing with data that is linearly separable, the goal of the support vector machine learning algorithm is to find the boundary between classes so that there are fewer misclassification errors. However, the problem is that there could be several decision boundaries, B1, B2, as you can see in the following figure. The objective of the support vector machine algorithm is to maximize the margin. The margin of a linear classifier is to increase the width of the boundary before hitting a data point. The algorithm first finds out the width of the hyperplane and then maximizes the margin. It chooses the decision boundary that has the maximum margin. So, for instance, in the above figure, it chooses B1. There are some advantages and disadvantages of the support vector algorithm. On the advantages side, support vector machines are effective when dealing with high-dimensional data where the number of dimensions is more than the number of the training samples. Support vector machines are known for their use of the kernel function, making it a very versatile algorithm. And on the disadvantages side, support vector machines do not calculate probability directly, and instead use a 5-fold cross-validation to calculate probability. With high-dimensional data, it is important to choose the kernel function and regularization term, which can make the process very slow. The logic behind having a large margin in the case of a support vector machine is that they have a lower generalization error as compared to small margins, which can result in overfitted data. With linearly inseparable cases, such as that illustrated in the following figure, we cannot use a hard margin classifier. The solution is to introduce a new kind of classifier known as soft margin classifier using the slack variable. Note that hard margin refers to the fitting of a model with 0 errors. Hence, we cannot use a hard margin classifier for the preceding figure. A soft margin, on the other hand, allows the fitting of the model with some error, as highlighted by the points circled in blue in the preceding figure. A soft margin support vector machine works by 1. Introducing the slack variable, and 2. Relaxing the constraints, 3. Penalizing the relaxation. The objective function for linearly inseparable data points is obtained by minimizing the following equation. In this scenario, we can use the concept of a kernel which creates a nonlinear combination of original features, x1 and x2, to project a higher dimensional space via a mapping function, pi, to make it linearly separable. A kernel can also be interpreted as a similarity function and lies between 0, an exactly dissimilar sample, and 1, an exactly similar sample. Why don't we go ahead and do an exercise to understand these concepts better, training a support vector algorithm over a dataset. In this exercise, we will be using the Titanic dataset named train.csv, placed in the Lesson 8 folder on GitHub. This dataset contains passenger information such as age, sex, class, and so on, and tells us whether the passenger survived. Our objective is to use this information to find out whether a given passenger is likely to survive. 0 means the passenger died, and 1 means the passenger survived. We will use the support vector machine algorithm to build our model. First, we would like to import pandas, numpy, train test split, cross-val score, and support vector machine from the sklearn library. Now we are going to read the dataset into a data frame named Titanic_data using pandas. And then we are going to look at the first few rows of the data. Let's check the data types as follows. Now I'd like to look for any missing values using the following code. Let's convert the data in the sex and embarked columns to categorical type using the cat.codes function, and look at the data types again using the following code. We're going to perform missing value imputation on the age and cabin columns Replace the missing values in the age column with the mean and those in cabin column with 0 if no value is present and with 1 if some value is present, using following code. Now it's time to split the data into train and test sets and save them as xtrain, xtest, ytrain, and ytest. We are going to fit a linear support vector machine with the C value equal to 1. C is the penalty cost parameter for regularization. Please refer to the objective function for linearly inseparable data points in support vector machine algorithm. Let's predict on the test data. We need to calculate the accuracy score using the following code. For the Titanic dataset, the support vector machine classifier will score an accuracy of around 76.6%. This implies it can predict 76.6% of the test data accurately.